The third stage of urine formation is tubular secretion. This is the movement of molecules from the capillaries to the renal tubule. Whatever ends up in the renal tubule will become urine. There is no more absorption beyond this point. So let's take a look at the capillary, which is the peritubular capillary. This is also a fenestrated capillary. The part of the renal tubule that does most of the tubular secretion is the DCT. So let's imagine that this renal tubule section is the DCT, and molecules move from the peritubular capillary to the DCT in the opposite direction as we've seen before. 4 is the peritubular capillary, 3 is the interstitial fluid, 2 is the tubular cell, and 1 is the lumen. So we're going backwards, 4, 3, 2, 1. The molecules that get secreted are potassium, hydrogen ions, and some toxins. Let's consider the secretion of potassium from the capillaries to the renal tubule. It is important to get rid of potassium from the blood because too much potassium in the blood can cause cardiac arrest. So we have to go backwards. 4 is the capillary, so the potassium must leave the capillary, and 3 is the interstitial fluid. Now the potassium must enter the tubular cell, and then it must leave the tubular cell to enter the lumen. So we have potassium leaves, potassium enters the tubular cell, and potassium leaves the tubular cell. Potassium leaves the capillary via simple diffusion because the capillary is fenestrated, so it's easy for the potassium to leave. Potassium enters the tubular cell via primary active transport. If you remember, sodium was pumped out of the tubular cell via primary active transport. There's a sodium-potassium pump here, so the potassium is pumped into the tubular cell. Then potassium leaves the tubular cell via facilitated diffusion to enter the lumen. Once it enters the lumen, it leaves out as urine. Let's consider the secretion of hydrogen ions. If there are too many hydrogen ions in the blood becomes too acidic, and a condition known as acidosis results. The hydrogen ions ultimately come from too much carbon dioxide in the blood. So when carbon dioxide mixes with water, it becomes an acid, and that acid releases a large amount of hydrogen ions. So here's the carbon dioxide leaving the capillary fairly easily, diffusing out of it, and diffusing into the tubular cell. Once inside the tubular cell, the carbon dioxide mixes with water and becomes carbonic acid. The carbonic acid then dissociates into hydrogen ions and bicarbonate ions. If the carbonic acid levels increase, that's the carbonic acid H2CO3, when that increases, the level of hydrogen ions also increases. And the hydrogen ion levels increase within the tubular cell. So there you can see the hydrogen ions increasing. So this hydrogen ion is pumped out of the tubular cell via primary active transport. And once it leaves the tubular cell and reaches the lumen, the hydrogen ions leave the body along with the urine. In this way, the kidneys are able to achieve acid-base balance.